Now that you've got an idea of what trinomial factoring looks like, we're going to look at some special cases of it. So the first thing we want to discuss is that trinomial, the prefix tri means 3. So trinomial factoring only works when you have 3 terms. There's only 2 terms here. So what can I do to fix that? Well, it just so happens that we're missing the middle term here. If we were to write it out as a true polynomial, there would actually be an x squared, a 0x, and a minus 9. So these are the same thing. The difference is this has 2 terms and this one now has 3. So we're going to ignore this and we're going to focus our attention down here because this is now a trinomial. And we know that trinomials have to multiply to be the back number and add to be the middle number. Now you might be wondering how we're going to get 0, but it does work out quite nicely. In order to get 9, I could either try 1 times 9 or 3 times 3. 1 times 9. I could probably get that to work out to be a negative 9, but is 1 plus 9 ever going to get me 0? No, there's no way I can make that happen. So let's work with the 3. 3 times 3 could get me 9. Maybe if I make one of the 3's negative. So negative 3 times 3 is in fact negative 9. But I have to check. Does that also work down here? Is negative 3 plus 3 0? Yeah, it is. So I've found my numbers. It multiplies to be negative 9 and they add to be 0. Recall that that's all I really need. The rest of it's just a matter of writing it down. Once you have your setup, you take the 2 numbers that you've selected. We chose negative 3 and positive 3 as our proper answers. So we put a minus 3 here and a plus 3 here, and we are now finished. So if it has 2 terms, you can usually rewrite it with a 0 in the middle and proceed from there. Next case that you're going to see is what if it's to the 4th power? It's different, but does that change things? No. You still have 1, 2, 3 terms. As long as it has 3 terms, you can do trinomial factoring. It needs to multiply to be negative 15 and add to be 2. Now you can mess around with this for a while, but to save time, I'm going to tell you that it's a version of 3 and 5. Now, 3 and 5 don't make 2, so I've got to kind of guess and check. The 5 might be negative, the 3 might be negative, or maybe they're both negative. I'm going to have to play. I'm going to think ahead of time though. How can I get a 2? Should I have the 5 be negative or the 3 be negative? I think if I make the 3 negative, it will work out. 5 times negative 3 is negative 15. 5 plus negative 3 is in fact 2. I was able to guess it right the first time. So when I get ready, the one thing that changes here is that we do have an x to the 4th. So rather than writing x, we're going to write x squared in those first 2 positions. And then we just take the numbers like normal. So I chose a positive 5 and a negative 3. So plus 5 and minus 3. The last example combines both of those ideas. First, a trinomial has to have 3 terms. So I have 2. Can I possibly come up with a third? I can. I have 1x to the 4th. I could have 0x squareds, and then minus 25. So again, if it has 2 terms, see if you can come up with a third term. Then we can do trinomial factoring. What times what is going to get me negative 25? And what added to what is going to get me 0? Well, 25 is either 1 times 25 or 5 times 5. I think I'm going to have a better chance with my 5s. In order to get 0 here, I'm going to need one of them to be positive and one of them to be negative. Let's check. 5 times negative 5, yes, that is negative 25. 5 plus negative 5, that is in fact 0. So I've found my 2 numbers. Let me bring my problem back. Recall that it was x to the 4th. So as discussed in the previous problem, that will make both of these x squareds. And then I'm going to carry these. I chose one of my 5's to be positive and one of my 5's to be negative. So I will leave that as my answer. I just realized that there's one more that I did not get to discuss with you. So here we go. Making this up on the run. What if I want to factor this? Well, as we've seen, it only has 2 terms, so I've got to come up with another one, which is fine. I can come up with a 0 as the inner term, and now all of a sudden I have 3 terms. Since it is a trinomial, I'm looking for 2 numbers that multiply to be the last term, and the same 2 numbers need to add to become the middle term. Now we've seen this before. 3 times 3 seems like a good choice. 3 times 3 and 3 plus 3. And now I need to make them both true. Is 3 times 3 9? Yep. Is 3 plus 3 0? No. Okay, so I've got to maybe put a negative sign in here. What if I make the first 3 negative? Negative 3 plus 3 is 0, so my bottom equation works this time. Negative 3 times 3, that's not 9, so that doesn't work up here. So I can't have that either. Now we can mess around with this for a while, but it turns out that you cannot possibly get both of these to be true statements in this case. So sometimes there are things that are not factorable. If you've looked at all of the possible different combinations of how to make this true and nothing works, maybe it's just not factorable. Sometimes it's better to just leave it alone than try to force something that's not going to happen. Good luck.